Hi there, this is a summary of section 1.1 and 1.3. Now this is just going to be a quick summary of those sections. We're really not going to spend a lot of time. This is all review. You should already know. So basically, if you go to your video notes, and you'll see at the very top our vocabulary: order of operations, formula, expression, and equation. Our objectives are going to be to use the order of operations to evaluate expressions. We're going to use formulas. We're going to solve equations using properties of equalities, and we're going to translate verbal expressions into algebraic expressions and vice versa. So basically, you need to know the order of operations, which is basically PEMDAS, which is please excuse my dear Aunt Sally. And you'll see it written as PEMDAS. These are symbols of inclusion for P. E is going to be exponents and radicals. MD, you notice, are next to each other instead of on top of each other like P and E, means multiplication, division from left to right in order, from left to right. So you can have multiplication, division, division, multiplication, division, division. You just go from left to right. You don't pick multiplication first and then go back and do division. Same thing for this next group, which is addition and subtraction. And if you look on your sheet, it says evaluate the expressions inside grouping symbols. Know what grouping symbols are: parentheses, braces, brackets, division bar, distribution, absolute value. Those are all considered expressions inside grouping symbols. Okay, next thing, expression and equation. Know the difference. So an algebraic expression is one or more term that does not have an equal sign. So for instance, 2x, 2x plus 3, 2x. So examples are 2x, 2x plus 4, t plus 3y minus 6. These are all expressions. 5 is an expression. There is no equal sign. An equation is two expressions equal to each other, two or more. Okay, so this is an equation because it's got an equal sign between the two expressions. Basically, you need to know the difference. And a formula is a formula to solve something. For instance, area of a rectangle. It's going to be length times width, right? Volume of a rectangle, it's length times width times height. And if we're given 3 of the 4 for volume pieces, we can solve for a missing value. Okay. You need to know how to translate into verbal expressions. So, but before we get there, when we are evaluating an expression, basically, we have example 1. It says evaluate this expression. So basically, you're substituting 3 for m and p for -4, and then you're using your order of operations to solve this. Okay, so you can see here clearly we've got 12 plus parentheses 3 minus -1 square. Now this becomes, using 3 plus 1 square, this becomes 4 square. 4 square is 16, 12 plus 16, and we simply get 1028 as our solution. Okay? So you need to pause this and try the guided practice 1A and 1B. Make sure you know how to do these. Okay? We go to the next page, and we've got example 2. A little bit more complicated if you look at 2B. So you go in and you plug in the values for the letters like they did right here, and then you use order of operation to simplify it. When you do it correctly, you end up with -47/39. Okay, so here again, you need to pause it and work the guided practice. Okay, So if we look at, whoopsie, we look at our summary sheet again, we've got a formula. So here they give us a formula for the volume of a cone, which is V equals 1/3 pi r squared h. And we can use this to approximate the volume of a tornado. So they give us the radius of that tornado and they give us the height. So that's what's missing. And you can use 3.14 for pi. If you use your calculator button and hit second clear and put enter pi, you're going to get a different value. You're going to get what the book gives you. But if you substitute 3.14 for pi when you write this out, you're going to get a very different value than the book has. And that's okay. And for our class purposes, you should use just 3.14. The other thing that you need to be aware of is these two properties are so important, and this is what you use to solve an equation. We already said an equation has an equal sign between two or more terms or expressions, or between two expressions. So the addition/subtraction property says if you add something to the left side of the equation or subtract it, you must do the same thing to the right. So for instance, if I wanted to solve this equation, okay, I want to get rid of 2, so I decide I want a -2. Well, if I minus 2 over here, I have to minus 2 over here. So as long as what you do to the left side, as long as whatever you add to the left side or subtract it, you must do it to the right side, and you've not changed the value of this equation. You've just renamed it, rewritten it. Likewise, the multiplication/division property says as long as you do it to every term, it's not real clear. It says both sides. Well, in this equation, you have to know what a term is. A plus or minus separates a term. I only have two terms, one on each side. So if I divide this term by 3, I must divide this term by 3, and I get x equal 4. Now, what if I had this? 2x plus 6 equals 12. And I decide I want to divide this term by 2. Well, in order to use that property correctly, I have to divide this by 2 and this by 2. So every term of the equation, therefore, it does not change the value of this equation. And then you can continue and using the properties. So know those properties. Pause this, attempt the guided practice. 4A. Or actually, no, this, yeah, you can do 4A. And then 5B, and this is going to be from section 1.3. You're trying to follow along in the book. Now, let's continue. Let's look at this standardized test example here. Okay, so it says, if 6x minus 12 equals 18, what is the value of 6x plus 5? You're like, that doesn't make any sense. Well, let's look at this a little closer. So the left side says it's got the 6x, but it's got minus 12. Can I change? I want to change this minus 12 to a plus 5. What do I need to do that in order to make the result plus 5? Well, if I add 17 over here, guess what? This becomes 6x plus 5. But remember, I have an equation. I have to follow my properties and rules. So this would follow in the addition property. If I added 17 to the left, guess what I have to do to the right? Then I get 35. So they want to know, what is the value of 6x plus 5? It equals what? Then you come over here, and it equals 35, which is the answer C. So try the guided practice 7, which is next on the sheet, and then check your answer. If you have any questions, we'll go over this in class. So this is just a quick summary of the 2 sections. You should be aware of it. This is Algebra 1 TEKS and concepts. So we'll see you in class.